For example 3, which, according to Sophie, is the Lamborghini. So, I don't know, some sports car. A sports car speedometer registers 50 miles per hour as it passes a patrol car stationed at a mileage marker. 4 minutes later, the car passes another patrolman at a marker that is 5 miles from the first. The driver notes that the speedometer registers 55 miles per hour. Can the highway patrol use the mean value theorem to prove that the driver was exceeding the speed limit of 70 miles per hour at some time between the 2 mileage markers?
Logically? I don't think so.
That's pretty fast.
Math-wise?
In other words, what we're saying here is there's math to prove it. That's what we're going to look at, is there's math to prove it. And what I'm trying to figure out, though, is why is someone going 50 and 55 in a 70 mile per hour speed limit zone? But, you know.
And also,
It's not
85, and he's speedy.
In a sports car, too.
Yeah, that's low.
Yeah.
You'd be going 75.
Okay,
Probably 95.
So, with this in mind, okay, let's see, what do we need to talk about here? So, first of all, notice our numbers are given in
MPH.
miles per hour, right? However, what else do we need to pay attention to?
Miles and minutes.
And we talked about 4 minutes, right?
Yeah.
That was the only minute thing.
4 minutes and 5 minutes.
Okay, so if we're talking about miles per hour, but then we're talking about minutes, we should probably get this all in one
Minutes.
unit.
Hours.
I'm going to go hours because I don't want to have to mess with converting miles per hour. And miles per hour is more what we think. So, let's see. The idea is we have this point A, which I'm going to, I'll call it point A, I guess. Time t equals 0, yes? And then we have this point B. If we're trying to work this whole problem in terms of hours, what is 4 minutes?
4:15 an hour.
And how do we get that?
4 over 60.
Yeah. So here, if you're thinking 4 minutes out of 60 minutes, that is, actually, I'm just going to put that right here. 4 out of 60, 4 minutes out of 60 minutes, which is 1/15 of an hour, right? Okay. Now, what does T represent here? And I'm just trying to get some basic information down here. Okay.
Hours.
T is your time in hours after the car passes, right? So I'm going to say T is time in hours after passing, or the first patrol car. First patrol car in the problem, A in my picture, right? Okay. And then if we talk about a function, okay, you can name your function whatever you want, but it's a distance, it's a position. So I'm going to use S of t, and that's going to represent the distance we've traveled in what unit? In miles, right? So, and that is, so let's see, how do I want to, this is the distance in miles from, I guess I should say first marker instead of first patrolman, but now, in order to do this, mean value theorem, right? We're talking about the mean value theorem. We're talking about the beginning and the end. How are we going to find, I guess I want to say average. How are we going to find the average here? What are we essentially finding?
Rolls.
A rock? Okay. we're essentially going to be finding AROC, our average rate of change. Sorry, my BenQ is starting to glitch out on me. Now, if we think about AROC, with AROC we use our two endpoints, yes? My endpoints that I have right now are t equals 0 and t equals 1/15. So in order to do AROC, remember it's y minus y over x minus x, I'm going to express this as s of 1/15 minus s of 0 over 1/15 minus 0. Now, with this in mind, so s of 1/15. Remember, I defined s, it's our distance formula, right? Or our distance, not formula, function. Okay? Our distance from the first marker that was at t equals 0. So s of 1/15. What is our distance there? How far are we from where we started? 5, right? And that was, sorry, had to find it there. Okay, that is our 5. Minus, what's our position at time 0?
0.
That was 0. Over 1/15 minus 0, yes? Okay, so what do we have here?
Oh, I did it kind of a different way, but I got the same thing.
That's possible. It's, yeah.
Okay.
Just do 55.
Yeah, I did 55 minutes.
Okay.
That's what I was
That's
thinking
right.
too.
Okay, fair enough.
75.
Because we would be doing 5
Times 15 over.
times 15 over 1, which is 75. What is that?
Miles per hour.
That is 75 miles per hour.
So he did go over this point.
At some point,
That's so crazy.
really at multiple points, because
In a bad
if it's your average rate of change, you didn't just go 75 once.
If you went it once, then the average would be lower.
Yeah.
right?
If I was driving a Lamborghini, I'd go over the speed.
Fair enough.
That's crazy.
So-
that you could do math to figure that out.
I think it was in my old calculus notes with my previous book, that there was a scenario in one of them that said, like, in a courtroom, could the mean value theorem be used to prove something like
That's
this?
crazy.
So,
Yes, the answer is yes.
okay, so the question was, can the highway patrol use the mean value theorem?
Yes.
And yes. So therefore, yes, by, I'm going to abbreviate MVT, the car was traveling at 75 miles per hour at least once between 0 and 4 minutes. Okay, so that is a application of mean value theorem. Now, did you maybe have an idea of it first off, and just not really realizing it's an actual theorem? Very possibly. So, okay, you ready for 4? Let h of x equals 5 minus 4 over x. Find all values of c in the open interval 1 to 4. So, guaranteed by the mean value theorem. So first of all, it says the open interval of 1 to 4. So what's that mean?
Right there to the 4.
Right there to there? Okay. So mean value theorem Remember, we're talking about,
A line.
well, yeah, the secant line, and we're talking about what? A-rock and I-rock equaling each other, right?
So a parallel line to that,
You
which should be at 2, right?
Oh my goodness.
So sorry.
No, I'm not, oh my goodness, yeah, you. It was like, I totally, still not happy with my line.
It's okay, mine's not
That's like the best option though. Like that's like my third or fourth attempt, and that's, we're just going with it, okay? All right. Now, remember, mean value theorem was the idea when we talked about it, basically that I-rock has to equal A-rock, right? With that in mind, okay? And I don't care what order we set this up in. And here's the deal, guys. Can you see, is there going to be something that works? Yeah, it said find all values of C. There's definitely going to be something there because you can see there's going to be a parallel line here, isn't there?
Yeah.
At what exact value?
2, 3.
I mean, we can guess it's going to be there. We'll find that for sure here in a moment, right? We did a lot of guessing and got good at that yesterday. Okay, so how do I find A-rock?
2 ones.
Okay.
You minus y1 over x.
And this is using the ordered pairs,
Oh, it's just regular slope.
okay, because it's slope of the secant line. So I'm going to write this as f of 4. Wait,
H of 4.
yep, that's exactly what I was like. Okay, h of 4 minus h of 1 over 4 minus 1, yes? Are we there? If we want to go ahead and clean up that side, what do we know? H of 4, this is going to be 4 minus 1 over 4 minus 1, which is going to be 3 over 3, which is 1. Fair enough?
Yeah.
Okay. I-rock. How do we do I-rock?
Derivative.
Derivative, yes? Now, before we talk derivative, I'm going to squeeze this in right here. Let's rewrite h of x. How should I rewrite h of x?
H minus
5
oh yeah,
minus 4 to the negative x.
4x.
4x to
Oh.
negative 1?
4
Just
to the
kidding.
negative x.
Okay, because when there's an x in the denominator, to get that out of the denominator, we use a negative exponent to bring it up, right? Okay. What, you talked about negative exponents in chemistry? Okay, so what's my derivative?
4x to negative 2.
Are you with them?
Yes.
Yeah.
We'll have one.
I mean, I'm with them, but
Yes, I am. Out there, but
derivative of 5 is
0.
nothing. Negative 1 times negative 4 makes it positive 4. Subtract 1. Now, so this is 4x to the negative second. 4x to the negative second. How can I also express this? This is, are you with me? Okay. 4 over x squared. How should you solve?
Multiply both sides by x squared.
Multiply the x squared over, so then we're going to have x squared equals 4. And then square root, what do we get? Technically, we do get plus or minus 2. What's the key in our problem?
We've only got it's
It's from 1 to
between
4.
We're on the interval 1 to 4, so really it's just x equals 2, yes? So, find all values of c in the open interval 1 to 4, guaranteed by the mean value theorem?
2.
You guys had already guessed 2, hadn't you?
Yeah.
And that works, doesn't it? It looks about right. So, I'm going to say, therefore, c equals 2 satisfies the mean value theorem on 1 to 4. Okay. Two down, two to go.
Let's go, let's go, let's go.
I see some excitement happening.
Calculator.
We're almost there. Oh.
I saw Natalie get her calculator out of the corner of my eye, and I was like, huh, must be something we need it for in the next one. And then I flipped, I'm like, oh, calculator symbols, so. Okay. MVT allows us to identify exactly where graphs rise or fall. So, the idea here, functions with positive derivatives are
Increase.
increasing functions. We've kind of already talked about that, right? Functions with negative derivatives are decreasing functions. Okay, we talk about that a lot more in this lesson, or in this, not this lesson, but in this unit. Okay, now, example 5. Find all values between the x-intercepts for which Rolle's theorem holds for the roots of f of x equals 4x squared minus x to the fourth. Verify with your calculator.
We just.
So if we're talking, it talks about for which Rolle's theorems holds, yes?
So it's going to equal 0? Or they're going to equal the same?
They're going to equal each other.
Yeah.
Okay. Before we go there, though, what do we need to verify to even start this problem?
That it's continuous.
Is this function continuous and differentiable?
Polynomial.
Okay. It's 4x squared minus x to the fourth. I don't necessarily know what this x to the fourth graph looks like, whether it's a parabola or a W or actually upside down, you know. So with that in mind, though, polynomial makes it continuous and differentiable. Okay. So I am going to state that. That is always something good to state. F of x is continuous and differentiable since polynomials are continuous and differentiable everywhere. Or even just since polynomials are continuous and differentiable. Actually, I think you could even just say because it's polynomial. Because we said so. Well, we need a little bit more than that, but yeah. I mean, it's a polynomial. That says it right there. Now, with this in mind, okay, I've heard there was some graphing, yes? Let's see. Find all values between the x-intercepts. So when it says find all values between the x-intercepts, we need to figure out what our interval is here that we're talking, don't we? Because right now, I don't have an interval that I'm working on.
-2, 2.
Have we graphed it?
Actually,
Yes.
-2 to
You have a symmetric looking M. I haven't graphed it on my own today. I'm going based off of what's here, but it's a symmetric looking M, yes? Okay.
BT.
And so it specifically says between the x-intercepts. Between the x-intercepts is how we can use Rolle's theorems, right? Because x-intercepts are going to equal each other.
Oh, okay.
What are those x-intercepts?
Negative
Negative
0.
-2 and +2, and technically it does touch at 0, right?
Yep.
Okay, so Rolle's theorem, if you recall, and I guess I don't necessarily have it stated here, but when we looked at some yesterday, the endpoints have to be the same. Is that happening here? Technically we have, if we look at this as two intervals, we have 3 endpoints happening, don't we? So we know that, what, f of -2 is equal to f of 0 is equal to f of 2, right? That's one of our requirements of Rolle's theorem. Now, we are specifically being asked find all values between the x-intercepts for which Rolle's theorem holds for the roots of f of x. What is it we're looking for here then? Here's your secant line.
So it refers to the topics.
Remember, this refers to our
Max.
mins and maxes.
Well, that was right.
Extrema.
And I guess technically, we can talk about that. It's an x-intercept, but actually I think more we're working on the whole interval. I don't have that part written down in my notes, which is why I'm trying to think on the fly here. But we're working on the whole interval because then you've got a max, and a min. So there's going to be 3 places that have a slope of 0, right? So when we set this up, we are looking for no, wait a minute. Oh, I don't need to do that. That's over. Okay, you know what? That's where I'm confused myself. I have this worked out algebraically to find the 0, 2, and -2. Do I need to do that? No, because that was the calculator. So I'm going to move on to the next part, which is the whole
I've really had questions.
derivative, which is where I was confused. But yes.
Why is the 0 marked out and the 0 marked out?
Okay. So I took the 0 out. Sorry, I'm processing in my head how I want to say this. I took the 0 out because we're talking about the x-intercepts. And so this right here is setting my interval. So in other words, the idea is our interval is going to be from -2 to 2. So our endpoints have to be the same. And our endpoints are going to be the -2 and 2.
Okay.
Okay. In my brain, I was thinking we were thinking of it as 2 until I realized, but that's a minimum there.
Yeah.
So that's actually going to count as part of one of the values we can find. Sorry.
Okay.
This is where I didn't look at this one as much beforehand as I should have, and you know. Okay, so with this in mind, to find these pieces, we need to look for when slope is 0. So we want our derivative equal to 0. What is our derivative?
8x
minus 4x.
Are you guys with them?
4x third cubed, sorry.
4x third. Okay. I wrote that really weird. I'm struggling today. Okay. Let's talk solving.
You can factor on 8x.
I wouldn't factor on
You can
8x.
factor out 4x.
I see a GCF of 4x.
The 8x give you 1 half.
Yeah, but
I wish
no.
we did. We're not doing
We're going to go 4x. You go 8x, meet me in the end, you'll get the same answers. I personally am going to factor out GCF of 4x. If we factor out GCF of 4x, what do we get?
2 minus x squared.
2 minus x squared, yes? And so then, what do we have?
Set equal to 0.
Set each factor equal to 0.
Negative.
So 4x equals 0 and 2 minus x squared equals 0. We got x equals 0, right? I'm personally going to add the x squared over. X squared equals 2, so what is x?
The square root of 2.
Plus minus.
Plus or minus?
Well, I think that's a given. It's
Okay.
in the square
Yes.
root.
So 0 and plus or minus the square root of 2. These are, for language sake, these are what we call our critical numbers. And again, I'm not sure how much we've talked about critical numbers because we talk about it more in this unit than anything, I think. But critical numbers, places your derivative equals 0. Okay? So, Find all values between the x-intercepts for which Rolle's theorem holds for the roots of f of x. I guess it said then verify with your calculator. Does this work? Does this make sense?
Yeah.
How do you do the thing on your calculator where you find, like you plug in like square root of 2, and it'll show you on the graph.
Hit trace
Trace.
and then type in your value.
Oh.
While you're on the graph, hit trace and then type in square root of 2 and it will show you what the max or min is, or max in that case is. Okay.
Thank you.
Okay. For the interval -2 to 2, Rolle's theorem applies for x equals 0, square root of 2, and negative square root of 2. Okay. So we retained something from yesterday. Remember Rolle's theorems, the endpoints have to be the same, right? When the endpoints are the same, that means it's a horizontal secant line, which means horizontal tangent lines, mins and maxes. Okay. One more?
Yeah.
Okay. Determine whether g of x equals sine of 2x plus 2x satisfies the hypothesis of the mean value theorem on the intervals 0 to pi. If so, find all numbers c in a and b such that g of b minus g of a equals g prime of c times b minus a. Now, what you don't realize, you guys are just a little freaked out by this. That's really just an A rock equals I rock, but slightly moved around. Because what would A rock be?
B minus A.
Well,
Well, then.
it'd be g of b minus g of a over b minus a.
Isn't
Okay.
that like that one?
Equals I rock, which is g prime of some unknown value, right? So here is A rock equals I rock, yes?
All they did was multiply it.
They took the b minus a and multiplied it over, yes? So do you see it now? G of b minus g of a is going to be equal to g prime of c times b minus a. Which is not that you really want to think about this. This is also like a point slope form. Y minus y
Because it looks
equals
like
m times x minus x. All these connections. Okay. So, mean value theorem. What should I address as I get started?
Is it continuous?
Is it continuous and differentiable?
Yeah. Well, no. Well, yeah.
Because
Yeah,
it's
sine.
sine is
What sign?
Of course. Yeah. You're not living
Is
your
sine
life.
continuous and differentiable?
Yes.
Okay. Added to 2x, which is part of a polynomial. Polynomials are continuous and differential, so does it follow logically that this would be continuous and differential?
Yes.
Is this also a calculator problem? You could throw it in your calculator.
Yes.
Okay. So, I'm going to say g of x is continuous and differentiable since sine x and polynomials ouch, are continuous and differentiable. Okay. Come on, Vicky, we just gotta make it through 2 more classes after this. It really needs restarted. Okay. With that in mind, this is mean value theorem, right? So mean value theorem, and you could do this in different orders, but my endpoints don't have to be the same, do they? But let's go ahead and talk about what our endpoints are, which means in terms of endpoints, we need to find g of 0 and
G of pi.
g of pi. What do you got for g of 0?
1.
0.
Oh,
Sine
0.
of 0.
I was taking a guess. It's 50-50, and I wasn't going through it in my head.
Sine of 0 plus 0. So g of 0 is indeed 0. Okay, what about g of pi?
Sine of 2 is still 0.
So 2 pi.
No, it's just 2 pi.
2 pi is also 0. No, it's not.
G of pi is 2
No,
pi.
I'm thinking sine. I'm thinking sine of 2 pi. 2 pi is
There's no sign on the second one.
They don't have to be the sum of the same.
2 pi.
MVT doesn't have
I'm
to.
not
be.
sure.
Correct. And VT does not, that's fine. Okay. We're just finding the endpoints for upcoming pieces here. Okay. Okay. So, with MVT, what are we looking for? We want, it's still going to be AROC equals IROC, right? So if we're thinking AROC equals IROC, okay, how are we going to do AROC?
0 minus 2 pi.
Officially, I'm going to write it as g of pi minus g of 0 over pi minus 0. And again, I'm just official notation, right? We fill this in. What did you say it was? 2 pi minus 0 over pi minus 0. Do I have that right? And while we're here, what's that going to be? Are you guys with us on 2? Sorry, I know we should work both sides at the same time, but my brain gets going on AROC and I just want to finish it. Are we good? Okay. IROC. What do I need?
Cosine of 2x.
We need to know g prime of x, right? So,
Plus times
I'm going to work it out right
Sine
here.
of 2x plus 2.
times 4. No. Plus 4. Plus 2? I don't know. Sorry, guys.
Okay. The derivative of sine of something.
Cosine.
Times?
2.
Derivative of something, which, really I'm going to put that 2 out front. Are you good?
Plus 2.
Plus the derivative of 2x.
So you can't multiply that too?
No, it's a plus.
This 2?
No, the other 2.
This
You
2?
can't multiply that to the 2?
No.
Not that 2.
The other 2.
No, it's added.
Then it would still be 4, right?
Yeah.
Or can you
No,
just
'cause
not
it's
do
No, because 2 is.
There's no 4 in this problem.
Okay. Sorry.
Because 2 is married to cosine.
Yeah.
Okay. This is cosine of 2x, and so this 2x is the inside of my function.
Yes, I get that.
We cannot multiply this 2 to it.
No.
This
That's
is-
what I know.
This 2 is added. These are 2 separate terms.
Okay, so even if we had the cosine 2x times 2 plus 2, you couldn't add those 2's at the end together.
PEMDAS. PEMDAS. You have to
You're right.
multiply before you add.
You're right.
So this multiplies to this, and then we no longer have like terms. Does that answer it?
Yep.
Okay. I had to get the right lingo in here.
So why do we have the 2 in the front and in the back?
So this 2 is because the derivative of sine of something is cosine of something times the derivative of something
Oh,
is that 2.
And then we add the
And then this 2 is the derivative of 2x.
Okay.
Are we good?
Yes.
Got everybody down? Okay. Now, so,
Yeah, had me in the
two cosine 2x plus 2 equals 2.
You the way.
What would you like to do here?
The sirens, right?
Yes. Keep solving. What would we like to do?
Subtract the 2.
Subtract the 2. So then I have 2 cosine 2x equals 0.
Uh-huh.
Now what?
Divide the 2.
Officially, you can divide that 2 out front, yes? So then if I divide that 2 out front, I have cosine of 2x equals 0. And then Sophie says, I'm done. I went as far as I can, I'm stuck. Okay, so this is where I say, okay, think. What you have to think here is when does cosine of, I'm going to come up with, well, do I want to say x? When does cosine of something equal 0? Because then what we're trying to do is we're pairing those up. Okay, so when does cosine equal 0?
Oh.
Okay, my brain says pi over 2 and 3 pi over 2. But what's the interval in question?
0 pi.
So it has to be pi over 2.
Ooh. However, we're going to use both. Okay, so right here, hold on. We can agree. Are you with me here? Cosine, when does cosine equal 0? And cosine equals 0 at pi over 2 and at 3 pi over 2. Valid? So then what we can do is we can set these pieces equal to each other. So we're looking at the fact that 2x equals pi over 2 and 2x equals 3 pi over 2. Solve for x. How do you want to solve for x?
Divide by 2.
Divide by 2 or multiply by 1/2. So pi over 2 divided by 2 or multiplied by 1/2 and 3 pi over 2 divided by 2 or multiplied by 1/2. What solutions do we get?
Pi over 4,
3
pi
pi
over 4.
Pi over 4 and 3 pi over 4. What just happened?
They're both between 0.
They're both on 0 to pi, aren't they? And that's the thing you have to remember, and that's what I forgot about. We still have this 2 to divide them by. If you take 3 pi over 2, which is 1/2, and you divide it in half, you're at 3/4. Okay. What are we supposed to do? Find all numbers C in the interval such that that is true. So basically that was a variation of A rock equals I rock, right? Okay, so therefore C equals pi over 4 and 3 pi over 4 on the interval. On the interval 0 to pi to satisfy MVT. Okay,
I used to graph on that one.
I don't remember it.
It's pretty cool.
I will say, guys, this whole solving and thinking about the cosine, we did this back in pre-calc. Not saying you remember it, but I did teach this when that inside is different back in pre-calc. So
That was my worst. I could never understand.
Pre-calc was so easy.
I